Hello, scholars. We are now on to scale 5.2, where we're going to be really focusing on a certain type of quadrilateral that we call the parallelograms. So we talked about quads in 5.1, and now we are going down the family tree into parallelograms. See, when you were in middle school, a lot of those middle school teachers, they like to say that parallelograms were quadrilaterals where both pairs of sides are parallel to each other. But now that we're in high school, we're actually going to develop a few more theorems that will really help us with the problem solving. So for instance, we may care about like the opposite sides of a parallelogram. So like let's say that this was x and that side was 7. Somebody who knows this definition of parallelogram and knows that the opposite sides are congruent, and I would really like you to use the examples that we have here and how I like marked them in because these really kind of illustrate how the theorems work. So somebody who knows that the opposite sides are congruent in a matter of seconds can find that missing side pretty well. Let's go to the next one. So here we have opposite angles. So let's say that this is 75 degrees. And we want to find how many degrees angle X is. Now, if we know that the opposite angles are congruent, then we can figure out that that angle is 75 degrees as well. All right, the next one, we have consecutive angles that we also can call same side interior angles. You may have heard that phrase before. So consecutive angles or the same side interiors are supplementary. That's what's up. So, like if this angle was 60 degrees, then this angle would have to be 120 degrees, because supplementary means that they add to 180 degrees. And then the last property concerns diagonals. So let's say that this piece of diagonal, I'm just going to kind of get a different color pen here. So maybe we'll kind of just use this green part, just going from like P to M. So let's say that measures 3, and maybe we'll choose like the color blue to kind of show that other diagonal. So we're going from M to R, and we'll say, what's X? Well, it also has to be 3, and that's because the diagonals bisect each other. All right, so let's look at an example problem. So example 1 here, this is kind of your run-of-the-mill numerical problem, and we have on Delta Math some numerical problems today just to make sure that you can use these theorems appropriately. So we're going to start first with finding JH. So we're going from J to H. So we can actually see that the opposite side is 8, and therefore that side has to be 8. And by the way, when you're looking at a diagram, this symbol means parallel to. And I also like to give you what type of shape it is in the problem too, so you can kind of read the text. So if you know your property, that 8, comes really quick. And that's because the opposite sides are congruent to each other. Now we're going to go do LH. So I'm just going to go back to red on this one. We're going to go from L to H. So the comparable piece in the diagonal, this is diagonals bisect each other. That's the property that we're going to use. And we can find out immediately that side going from L to H is 6. And then we have KH, so that would be the total. So we would get the 6 plus the 6 for a total of 12. All right, the next type of problem that you're going to see are sort of the algebraic variety. Now, the good news is if you already know the property very well, I like to write down the property. So we have angles here that are marked. That's what these are referring to, not sides. And they are not same side angles, but they are opposite angles. And we could say that the opposite angles are congruent. And that means that we should set them equal to each other. So I could say that angle X, the measure of angle X, equals the measure of angle Z. So I could do 4x minus 9 equals to 3x plus 18. Oh, I like to keep a positive x. So I'm going to subtract the 3x. That gets me 1x minus 9 equals to 18. Add 9 on both sides. And we get that x is equal to 27 degrees. Make sure you're kind of putting that unit on there. Now, it says find the value of x on this problem. But sometimes I may ask, what is the total value of the angle? So to kind of check for work, and I'll do this in my green pen. And even if it doesn't, tell you to find the angle, this is a very good way to check your work. So I do 4 times 27 minus 9. And that's going to be 108 minus 9. You can just go to your calculator and figure out what that angle is. It should be 99 degrees. And then I could do 3 times 27 plus 18 for another total of 99 degrees. And things are checking out well. So we should be seeing that those opposite angles are congruent to each other. So just as a recap, when you're problem solving with parallelograms, always think about what property are you using of the 5 properties that we learned today.